I'm going to show you how to graph a couple of systems of inequalities. So right now I'm looking at the extra practice number 3, and the question is asking just to find the solution of the system of inequalities right here. So I'm going to transfer these over to my graphing sheet, but they're already written in slope-intercept form, so that's really helpful. So y is greater than or equal to negative 3x minus 1. And y is less than x plus 2. I'll do that in a different color. Y is less than x plus 2. So the first thing we do with these, if they're already in slope-intercept form, is we graph our boundary line. So I'm going to graph y is equal to negative 3x minus 1. I know that my y-intercept is 0, negative 1, so I'll put a point there. And I know that my slope is negative 3, so I'm going to go down 3 over 1. I'll do one more, down 3 over 1. And then I'm going to draw in a solid line because it's y is greater than or equal to. I'll draw my boundary line for y is less than x plus 2. So my y-intercept is positive 2. And my slope is 1 because there's essentially an invisible 1 in front of this. So I'm going to go up 1 over 1. And I can go down 1 over 1 just to give us an extra point. And then I'm going to draw my whoops. So just be aware. This, because it's y is less than, not less than or equal to, we need to draw a dotted boundary line because this boundary line isn't actually included in that inequality. Okay, now what we need to do is figure out where do these two graphs overlap. Now for the first one, the one in black, y is greater than or equal to negative 3x minus 1. So what that means is every point on this boundary line is going to include that point, and y is greater than, so then any point above it. So what we're going to do is we're going to shade above the boundary line for the black one. Okay? For y is less than x plus 2, y is going to be anything below this boundary line. So we would shade everything below that boundary line because it's all the values less than what that line represents. So now we're looking for where does our shading overlap, and it's in this region right here. You see how there's black and orange in all of this region? So I'm going to erase this shading so that it's more clear. And the only area where these two overlap, I'll put it in blue, is below the orange and above the black. So it's all of this. And then we're done. Now again, this shading would go to infinity as long as we're between these two lines, or in this region. Okay, this is number 2 on the extra practice. So we have two functions in our system. Y is greater than x, whoops. Y is greater than x and y is less than x plus 1. So first thing we're going to do is draw a boundary line. Y is greater than x. We have a slope of 1 and a y-intercept of 0, 0. So up 1 over 1, up 1 over 1, and then we'll draw our line in. I'm going to make it dotted because it's not greater than or equal to, it's just greater than. And then y is less than x plus 1. There, my y-intercept is 1, and my slope is 1. So up 1 over 1, up 1 over 1. Same thing, dotted line. So we have two parallel lines. They're not intersecting, but there is a region of overlap. So y is greater than x. I would draw, or I would shade everything above the blue boundary line, okay? Because y is greater than x, so it includes all the values of y above the boundary line. Y is less than x plus 1 would include all the values below the boundary line. So the region of overlap, the solution for our system of equations, is right in between this line, or these two lines. I can make that more precise. So right in between these two lines. So basically that's how you solve a system of equations using graphs when they're, or sorry, a system of inequalities using graphs. And what we'll look at next is absolute value function. Okay, here we need to find the solution to this system, which is already in slope-intercept form for us. So if I have y is less than or equal to 3, here's my y is 3, and that's just going to be a horizontal line. It's 0x, which means the slope is 0. I'm drawing a solid line because it's less than or equal to, and because it's less than or equal to, all the y values below this line will fit that. And then I have y is greater than or equal to the absolute value of x minus 1. Now this is where it becomes useful to be able to quickly graph an absolute value function. So I know that this absolute value function is just going to be a rightward shift of absolute value of x. So I'm just going to put a point at x minus 1. I know that my slope on the right-hand side, because there's nothing in front of this, is 1. So it's up 1 over 1, up 1 over 1. And that on the left-hand side, it's going to be negative 1. Up 1, left 1, up 1, left 1. If you remember, we had y equals a times the absolute value of x minus h plus k. In here, there's no plus k, so it's plus 0. And this is h. So h is 1, k is 0. So my vertex is at hk, which is 1, 0, which is exactly what I drew over here. So now I can put in my absolute value function. And remember, it's y is greater than or equal to x minus 1. So I'm drawing below the pink line, because it's y is less than 3, or equal to 3, and I'm drawing above the blue line. And so when I fill in, the area of overlap is in this triangle right here. Let's look at one more. So here I have y is less than or equal to negative 1/3 x plus 1. So my y-intercept for the line is 1. And my slope is negative 1/3. So I'm going to go down 1 over 3. Down 1 over 3. And I'll draw in my line. My line is solid because it's less than or equal to. And because it's less than, all the y values below this line would satisfy that equation. So I would shade below the boundary line. Next, I'll do my absolute value function. So because it's x minus 1, I know I'm going to shift to the right. And because there's no k, because there's no k, I know my vertex is at 1, 0. and this number in front of the absolute value function or term tells me the slope of the right-hand side. So I'm going to go up 2 over 1, up 2 over 1, and then the left-hand side is going to be up 2 left 1, up 2 left 1. And I'm going to draw that in. Because, again, got to be careful. I've done this twice now. These have to be dotted lines because it's just less than. It's not less than or equal to. Because it's greater than, I would fill in anything above this line, any y value above this line. But we're only looking for the area of overlap. So remember, we have to go beneath the pink line and above the blue one. And so there's only this one very small region that we would shade here. And it's right in here. So you'd have this little triangle is the only region where these two would overlap. So that would be it. That's how you would graph that one. So that's how you graph systems of inequalities.